Hello, good day, everyone. This is Engineer Igan. Today, I'm going to teach you how would you be able to tell whether your quadratic equation has a real and equal roots, or whether it has real and unequal roots, meaning it has two unique solutions, or lastly, whether it has imaginary roots, meaning it doesn't have any real solutions at all. Okay? So first is you should be able to identify your discriminant. The discriminant is this formula. Okay, this expression is found on inside of the radical sign of your quadratic formula, b squared minus 4ac. Now take note, if that the entire value of that discriminant is equals to 0, okay, I just want to make it clear that it has to be equals to 0 for your entire equation to have one real and equal roots, okay, meaning it has only one unique solution if the discriminant is 0. But if the discriminant is greater than 0, in this case, or it's positive, then you can say that it has real and unequal roots. Or in other words, you can say that it has two unique solutions. Okay, then lastly, if the discriminant b squared minus 4ac is less than 0, meaning negative, then it has imaginary roots. Or in other words, it has no real solutions. Okay? So let's move directly to our examples. Okay, in this case, we have x squared plus 6x plus 9 is equals to 0. All you need to do here is actually you just have to find your values. For a here is 1. That is the coefficient of your quadratic term, x squared. Okay. B is the coefficient of your linear term, the 6x. So the coefficient of that is 6. And then your c lastly is your constant, which is 9. Okay. Then after that, you just have to substitute all these values to the discriminant. Okay, b is 6 squared minus 4. Your a is 1, and then your c is 9. And then just further evaluate. 6 squared, you have 36. Minus 4 times 1, 4 times 9, that's another 36. And then it equals to 0. So as you can see, your discriminant here is equal to 0. So meaning, what does it mean? It means that it has real and equal roots, right? In other words, it has only one unique solution. Okay. How about for our second example? You have your 5x squared minus x is equals to 4x squared plus 2. Now, I want you to remember that before doing anything else, make sure that your equation is expressed in standard form. If it's not, then do everything you can to express it into its standard quadratic form. Okay. So all we need to do here is just a little bit of transposition. So 5x squared, I'll transpose 4x squared from the right side to the left side. This becomes minus 4x squared minus x minus 2 is equals to 0. Okay? And then further simplify. Combine terms. 5x squared minus 4x squared, you have x squared. Right? Minus x minus 2 is equals to 0. Question, have you already transformed? Have we transformed already the entire equation into standard form? Yes, we have. So now that we already have it in standard form, it's now time to define the values. Our A here is 1, your B is negative 1, right? And then your C is negative 2. And then easy. Substitute these values for this formula of the discriminant, B squared minus 4ac, right? So your B is negative 1, so we square that, minus 4 times your a is 1 again, and then your c is negative 2. And then further simplify. 1 minus 4 times 1 times negative 2, you have negative 8, right? 1 minus negative 8, that becomes 1 plus 8. And then you have 9. Good. So now that you have arrived to a positive answer, positive 9. So basically, as what I have discussed before, you can say that this one has real and an equal solution. Okay? In other words, you can also say that it has two unique solutions. All right? How about this? 2 over x plus 3 over x is equals to x minus 4. Now, you need to understand that what we're dealing here are quadratic equations. So in this case, what we have here is irrational expressions, okay? So what I'm gonna do is I have to get rid of the fractions. And to do that, the first thing I'll have to do is I'll find for the LCD the least common denominator. And in this case, the least common denominator is x. So all you need to do is you just multiply both sides by that LCD, which is x. So you just multiply both sides of the equation by that LCD. And then after that, you distribute. Multiply this here. X times 2 over x. X cancels out. You'll have 2 left. Plus. Again, multiply this here. Okay, that's what we call distribution, right? X times 3 over x. X cancels out again. You will have 3 left, right? And then do the same thing on the other side. Distribute here. This one, x times x, you'll have x squared. And then here to here, x times negative 4, you will have negative 4x. Okay, and then just further simplify. You'll have 5 here, x squared minus 4x. And then that becomes x squared minus 4x minus 5 is all equals to 0. Now that we have transformed the entire thing into its standard quadratic form, okay, all we have to do left is identifying the values. Your A here is 1, your B is what? Negative 4, and then your C is negative 5. All right? And then once again, substitute all these things into the formula of the discriminant. Your B here is negative 4, square that, minus 4. Your A is 1, and then your C is negative 5, right? Negative 4 squared, you get 16, minus 4 times 1, that's 4 times negative 5, you'll have negative 20. Then 16 negative minus negative 20, that becomes plus 20. So all in all, you'll have what? 16 plus 20, you have 36. Again, what we get here is a positive number, positive 36. So I could say once again that it has real and unequal roots, or it has two unique solutions. Okay. Lastly, okay, let's look at our last example. You have here 2x squared plus 3x plus 5 is equals to 0. Now in this case, you don't have to do any manipulation because the equation is already expressed in a standard form. So you go directly now to identifying the values. Your A here is 2, your B here is 3, and your C is 5, right? And then just substitute all of those values in this formula. So B being 3, square that, 4 times A, your A is 2, and then your C is 5, right? 3, you square that, it becomes 9, minus 4 times 2, you get 8, 8 times 5, you have 40. And then 9 minus 40, you have negative 31. Okay? As you have noticed, our answer is negative 31. It's a negative number. And because it's a negative number, as I have previously explained, then you can say that it only has imaginary roots. Okay? Meaning you can also say that it has non-real solutions. Either way. Okay? So that's it. I hope I was able to make it easy for you. But then if you believe that you still need something or further examples for you to be able to really grasp the concept, then please let me know and leave me your comment down below so I will be able to give you more videos with examples like this one. Okay, that's all for now. This is Engineer Reagan. Bye.